Hey, hello. Um, this week, this is like our big week of optimization. Also, sorry in advance, I'm going to be walking on my treadmill. I got to get my steps in. I don't know what to tell you. I got to get my steps in. But this week is benchmark week. So we're going to be working on getting optimizing some functions, making things a little bit faster. Uh, yeah, let's look at our to-do list. We've been tracking all the. Oh yeah, look at this. Oh, so much time wasted. 23 seconds rendering schematic traces. So we got lots of stuff to optimize and fix. I think this list, actually this one's even better. It's got the long times here. Basically we want to figure out how to make this faster. And we want to do so in a way that, whenever you optimize, you kind of mess up a code base. So we want to do it in such a way that we're making the code base or making it easy to maintain those optimizations, track them, make sure we know why they're there, stuff like that. So, yo, Rohit, what's up? Good to see you. I'm good. Maybe a tiny bit sick, just a touch of illness. But yeah, I want to somehow commit the results. We do this really great thing in core. Every pull request, when you look at it, every pull request that changes the package JSON file, I want to say, every pull request that does that, it has this nice bundle size report. And I really like this convention for making sure that you don't break anything in a really bad way. Because we can see this. This will sometimes go up by a huge, like 10 megabytes or something like that. And so we know we installed a package we shouldn't have. We knew we did something wrong. So I want something similar for benchmarking, but I've always struggled to do this with benchmarking. One, because they're just not the same every time. Bundles are actually a touch of illness. Yeah. The bundle size is actually consistent. Every time you build a bundle, it's guaranteed to be consistent, but benchmarks aren't guaranteed to be consistent. Maybe they would be if you had some kind of perfectly deterministic system, but as soon as you have HTTP requests and stuff like that, the system is no longer that deterministic. It's very probabilistic. And there's just no good way to really track that. That's obvious to me. So, I don't even know what to do in this situation. I was like, last night I was thinking, okay, I'll run nightlies. I think I even have some notes. We're going to see if we can create, something like this, probably, Rohit. Probably something like this, but for how quickly we execute. We want a report that kind of shows, maybe as a pie chart or something like that, each of these render phases and how long they take. Because we have circuits right now that take about a minute to render, which is pretty annoying. And you can see that some of our phases take a really, really long time. And so we're going to optimize this and make it so that these don't take as long. But before optimizing, you need to measure. It's really important to measure before you optimize. So we want to track how long these phases take. And then we'll build a test that replicates that, and then we'll try to do it. Bun has this thing called 2-match inline snapshot. It's one of my favorite features of Bun. And what it does is it kind of lets you take a snapshot of the data at a particular point in time. And it puts it in line, which I think is also really great. I wish I could do this for benchmarking. I wish I could say, hey, at this point in time, this took this long to execute. Sorry, I just got a message. Yeah, so unfortunately, there's not a super good way to have benchmarks match the same way. So I'm trying to piece this together. How can we do benchmarks in a way where we can track it pretty easily? I have no idea. Let's ask ChatGPT. Let's do what we always do when we're confused. Let's ask ChatGPT. So we got 4.0. I'm trying to track the performance of a rendering system in TypeScript over time to make sure for every pull request, we understand the performance impact. What is a good pattern or system for doing this? So let's generate some ideas. We're going to commit to the, every time I do this, I always hack something together, and it tends to be annoying to maintain. So let's see if we can get something more maintainable. Benchmark JS, baseline components, CI/CD. It's kind of like all obvious stuff. This is the stuff I always do custom. You know, I need a framework. Yeah, Benchmark JS just kind of tells you how long something takes to run. It's not really a framework for doing it. Store the performance data in a database. Okay. Sometimes with GitHub Actions, we commit the results to JSON. We do that in a couple repos where we automatically commit to JSON. The thing is in our core repo, it's kind of messy to do that. Something we could do is try workflow dispatching. So we dispatch a workflow out to a different repo that does the recording of the data, and then that repo can be quite messy. But because it's separated, I don't really care so much. But our core code base, it feels like we don't want to be constantly committing JSON files to it. Yeah, they're really recommending, you know, a pretty custom system. What are some NPM modules / frameworks that simplify this? I really think there's no solution. I certainly have never seen a solution to this problem. So, perf hooks. Yeah, these are all just for measuring time. Yeah, this sucks. And now it's recommending databases. It truly is just do it yourself. Yeah. Are you walking and coding at the same time? I mean, I'm not really coding yet, but yeah, I am walking on my desk. I know I shouldn't in stream. It's like a little bit distracting, but yeah, I have a walking treadmill. I need to get my steps in. Until I get my steps in, you guys are just going to have to deal with it. I don't know what to tell you. It is a little bit, you know, unprofessional, one might say, but at the same time, like, you know, look, we're doing the grind here. Okay, an HTTP benchmarking tool written in Node. How does it work? Autocannon takes a URL. Yeah, there's really not a sophisticated system for this. So let's yeah. How can we do this in a way that's clean? I want to do it in a separate repo because I think it's going to be so gosh darn messy. And having a database with the results, I hate that. It should be in version control. Man, I really can't believe there's nothing for this. But look, this is my goal today, is to optimize the hell out of these lines. So yeah, but man, it would be so nice to be able to just kind of maybe instead of having a separate repo, maybe we could do some kind of benchmarking tool. I'm trying to think what would be like the perfect CLI if we wanted to do this kind of continuous sort of benchmarking system. What would be the perfect CLI? Let's go to our Scratchpad. What's the perfect tool? It would be like, you would say like benchmark some file.benchmark.ts, and then it wouldn't just output the time. It would output like because we have all these phases, we have all these things we want to test. So it would be like output result dash timestamp or timestamp dash some file dot benchmark or result dot JSON, something like that. And then that file would contain kind of like, time spent in function, something like that. And then function name, like 1000, other function name, 2000, etc. Probably like a little bit more random. Something like that. Yeah. Num function calls. That's also good to have. Function name 32. Other function name 1032. Something like that. That feels like something you could cross compare relatively easily. I feel like that's the interface I want. So it outputs this file, but then I don't want to commit this file to the repo. Yo, what up, Ansh? Welcome. Good to see you again. I'm trying to figure out what the right structure is if we wanted to benchmark core so that we have a nice way to optimize. Can we use the GitHub proxy API for the maintenance tracker because of API rate limits? No. You have to fix the cache issue inside of contribution tracker. You gotta introduce a file system cache. I think I described it. I can't remember if I described it on Discord or in the repo, but it's totally unsustainable how many API requests the contribution tracker is making. So we need to introduce a file system cache. Looks like somebody already did, maybe. Oh yeah. There's the issue. This needs to be done. There's no way around it. You can mess around with other stuff. You can hack it all day, but ultimately, if there's a rate limit and you're not caching it, like you're just gonna it's not worth it. It's not worth it. Proxying GitHub API requests, that just moves the rate limit somewhere else. It would be nice if each repo had an individual rate limit so that the rate limits of some repos didn't interact with others. But also, I wouldn't worry about it. This is such a low priority issue, Ansh. Like, I mean, I do want to fix the rate limiting for other reasons, but as far as the maintenance tracker is concerned, it's effectively green. It's not, the little yellows now and then aren't too big of a deal in my opinion. I don't know. Really, OSM coding and walking at the same time? I'm struggling to even code properly. I code like I breathe. All right. Yeah, benchmark, some file. It outputs this kind of file. And then... So we have these files, and then we can visualize the difference. So maybe there would be something like benchmark delta file 1 dot benchmark result dot JSON file 2. Maybe we just do bm.json or something like that instead of laziness. It's such a long file name. So benchmark delta outputs the difference, the ordered difference between functions. So you can tell how performance changed. And and then you can like comment on a PR or something like that. So I think the GitHub integration is definitely the tricky part of a benchmarking system like this. So I think what I want to do is I want to use GitHub like a database. I want it to actually output to GitHub, not output to the file system. I mean, maybe it can use the file system, but I really want it to output to GitHub so that all the benchmark results are kind of stored somewhere. Benchmark run. Then we could say version like 1.2.3. And we could say writes to v123/ whatever. So that way you're tracking the version that the benchmark is run against. Yeah. Or you could do benchmark run, blah, blah, blah. And then the version can be like PR23, something like that. And then it'll write out to PR23, whatever, on remote GitHub repo. Using GitHub like a database is kind of tricky, though. Yo, what up, Absi? Coding Sage. I code like I breathe. Yeah, Sevi, I have checked today. I have 55 merged PRs on TS Circuit. Congratulations. That's a very good number. Let's get it to 100. More PRs. We've got a lot of work to do. Yeah, after I'm done with this board, after I get this board ordered, I think I'm going to look at the keyboard thing because that's another good project. Man, we have so many good projects to work on right now. I don't know how hard it's going to be to get this guy to consistently auto route. So that's what I'm currently a little bit worried about, our big board. So this rendering thing or this benchmarking is maybe not the most important issue. So I'm probably going to work on it like 2-3 hours today. And then we'll switch over to making sure that the auto router can auto route. But it's so annoying how long it takes. So I think like it'll just smooth things out to do these optimizations. So like, again, just getting into what would be the perfect interface, you would have. So it writes these things out. Maybe we do PR number, PR23. So it can write to directories, it can write to versions. So this is how like, it's like, I'm on main, I'm going to write this version, whatever. When I do delta, maybe I give it the remote version. So I say like, I want to compare main / whatever to PR23 file 1. So I want to see the difference between these. And then maybe I could also say -- comment on GitHub. So that could be pretty cool. And then you could probably run it locally. So for local testing of benchmarks, you could say something like benchmark run and compare .benchmark.ts. So it'd be something like that. Outputs delta between this file and the last good run. It would be really easy to just have a directory called benchmarks that kind of handles all of this, but I just don't like the idea of committing all these benchmarks to GitHub. There's also like, I guess, system. We should probably have something like system description, and then this could be like M3 Mac, etc. So we could try to look for the most relevant system when deltaing. It kind of does feel like it should be a database, but I wonder if I can use a remote GitHub repository as the database just to clean it up. Yeah, I feel like that would be pretty nice. I want to create my own keyboard and order it too. Absolutely. You should. I want to do some Micromod keyboards. Yeah, but I already did a Pico keyboard. I haven't done a full-size Pico keyboard. I think that'll be the next. I think the keyboard building tool might be the next thing. And that keyboard building tool, I think, will output to TS Circuit snippets. So basically, you build your keyboard, you output to snippets. Then if you want to do more modifications, you do it from within snippets. I think that's probably how I'll do it, rather than build a whole save loading system and make it like an independent app. It'll really just funnel into snippets. To me, that seems easiest for a bunch of reasons. Because otherwise, it's almost like building a completely separate app. Also, snippets will eventually have board ordering, so it'd be easier for it to just like, oh, okay, you go to snippets, you order the board. But I really want to get this board rendering quickly. Yeah, this is probably... Good night, Rohit. Thanks for stopping in. This is probably a good idea for the benchmark. So, let's talk to ChatGPT for a little bit. I want to use a GitHub repo like a database and post/git certain files. Is that possible somehow? So we know we can get files, but can we put them? Does that work? A commit message, the new file content, the SHA of a file. Okay, so apparently we can do that. And we probably just need the GitHub token, so we can use the TS Circuit Bot GitHub token. And then we could potentially do that. I mean, that sounds pretty good to me. So we can keep our benchmarks, our benchmark data in a separate repo. Do you have, what's a good chip for a professional keyboard? The most common chip for a professional keyboard is the Arduino Pro Micro. The Arduino Pro Micro is the most common microcontroller for a keyboard right now. But you can use any... really, the software is not the hard part. So I would use the Pico because everybody else is going to be building on Pico, and you can do it in Python. You can't use... To my knowledge, you can't use Python with this. So it's a little bit older. I think it's too slow for Python. 16 megahertz is really slow. It's considered very slow. So, and this is also more expensive than a Pico. So I would just use the Pico, and not the Pico 2, just the Pico 1. And just hook it up. It's really solid. What does it cost? 63 cents. The unit... Oh. No, the unit price is $6, I guess. But that's still less than the $20 for the Arduino Pro. They don't have that many of these in stock for some reason. Pico W. Do they have more Pico Ws in stock? Yeah, they have more Pico Ws. But they're all swappable. You can literally, if you want to, it's going to run probably the same code. The Pico 2, the Pico W, whatever. Yeah. The other thing I would consider doing is getting a SparkFun Micromod to work. That's a little bit harder. Honestly, I would just use the Pico. But if we get SparkFun micromods to work, you can see that these microcontrollers aren't as well stocked as other chips, like key switches, stuff like that. Key switches can have stocking problems too. But anyway, basically, for some parts, we want to make sure that we always have them in stock. And our microcontroller, since we build on it so much, we want to make sure it always has in stock. So if we build keyboards with the micromod, again, I would start with Pico. But for the next keyboard, I would consider doing a micromod adapter. One, because there are different processors available, so you can actually test out other processors. But the other really cool thing is you can order one of these, and if you get a new version of your keyboard, just pop it out, pop it into the new keyboard, and you're good to go. So it's like you could just have literally one or two of these, and then you'll never have to worry about the availability of the RP2040. And this has a couple things on it. Like, it's not just the RP2040. I think it has power handling, and then it might also have what else does it have? Yeah, MicroPython support, I would say, is a pretty good idea. USB. What is this chip? WinBond. Let's see if we can find a schematic on this. I'm just curious what chips they have here. So this is just a connector. As big and scary as it is, it's just a connector. That's the main microcontroller. And then, oh, it's flash. It's flash. Yeah, so it comes with the flash memory for your program. This is actually optional. You actually don't need this, I think. Or actually, no, you do need this whenever you use the RP2040. So that's good to have. And then a USB multiplexer. That's interesting. Oh, I guess this is... I don't know if you would need that strictly, but I guess it's nice to have a USB multiplexer. They thought it was important enough. Maybe it's so that you can power on USB or use it for programming. Something like that. I'm not sure. Anyway, I would recommend Pico. Strongly recommend Pico. If you do Picos, I will help you debug or micromod. For anything else, I probably won't have the time to, just because I have to pick a single piece of infrastructure to build on for most boards, just to simplify my life. Anurag, what up? A command line tool for tracking benchmarks and commenting to GitHub. We're gonna try to make this module in, like, I don't know. I'm gonna spend 20 minutes maybe on this module. We're gonna see how far we can get. I should have made it public. Yeah, I'll call it benchmark CLI. Now let's make it public. There's no reason to hide it. Back to getting those steps. I'm getting the steps. Yeah. I feel like it's a little bit distracting for stream content. It's not good content, but it's really good for your legs, I guess, to walk a lot. So I'm just gonna keep walking. I'm trying to increase my fitness lately, like to kind of like just make myself a little bit sharper, I would say. Because like when you have like back pain or something, you don't want to do things. Like, you naturally will it drags you down a little bit. So I'm trying to do, a little bit of yoga and then a little bit of weightlifting almost every day. And walking is really great too. Especially if I can work and walk, it's like two birds, one stone. All right. I keep looking at this thing so that I remember what I'm doing. This is our sort of description of this benchmarking CLI tool we want to build. Let's get to it. Let's just do it. I don't want to think too hard about whether or not I should be doing it because it's unclear. It's just a bet. It's just a bet. Yeah, might not work out. We will find out. Let's open up the repo. I'm going to paste in this kind of like description into a usage section. It's complaining. I need to initialize this repo. That's fine. We're going to add biome, our formatter. And then we're going to add a biome config that we like. Okay. So we have sort of a description of our program. Yeah, I think it's like relatively I think it's pretty good. Oh, is this going to do what I want? I think this will do what I want. Yeah, okay. Let's make this project a little bit better from an organization perspective. I always like to have a lib directory, so we'll paste in the index.ts into the lib directory. We're going to build with TSUp. I'll add that in advance. Always build with TSUp, which uses ESBuild under the hood. What else do we want to do here? Package JSON. Can add a build script. We're going to call this TS circuit / benchmark CLI. Yeah, I don't want to spend too long on the build system. I will stop actually. What do we want to use for the command line? Let's use Commander.js. So I'll add that. How do you concentrate while walking and coding and giving a reply in one go? I don't know, man. Do I seem like a very focused person to you? Yeah, I don't think so. Oops. Okay. Some of my hotkeys are not working because I'm in a markdown file, I guess. Ooh, what happened here? Okay. Oh, there's so much stuff going on. Add that VS Code file. I've never used the GitHub API like this, so we're gonna try to use GitHub like a database. We're gonna try to post the benchmarking files as JSON files to GitHub. Yeah, we're basically gonna use it like a database. I don't know if it'll work. I've never done it, so yeah, it'll be new. Before we use AI to generate most of this repo content, I'm like a little bit worried. AI will really generate like one file if you don't give it, if you don't tell it what to do. So, we have this pattern in another project where we have these directories for each CLI command, and then we have a register file inside for Commander projects. So I'm going to copy that convention here so that the AI picks up on it. So we have running compare. There was some other thing. Delta is a delta command. So that's for getting the difference. Actually, we should call it maybe compare instead of delta. Yeah, that's better. Okay, good night, Sevi. All right, good night, Ash. Thanks for Ansh. Thanks for showing up. Thanks for turning up. Yeah. Compare. So I'm just gonna add some bootstrapping in these files so that the AI knows what to do, ish. Um, yeah. I think that's pretty good. Bootstrap a Commander CLI based on the README. So we're going to bring in some light AI work here, and we're going to remove most of it, but it'll be a good starting point, I think. So I have this problem with Semvar, and it drives me nuts, but we're going to add Semver as a dependency. And then to get the current package version, we're actually just going to increment, we're just going to increment the package version by one, one increment. Because when you build it with an old version. I'm not going to get too into it. I think I talked about it maybe yesterday, but it's a really annoying problem with the build system where it builds for the last version of the module instead of the next version. Very annoying. We're just going to patch it this way. So for our version here, yeah, we just increment the package version. For some reason, we're getting semicolons. I have no idea why. We have semicolon disabled. I'm going to reload window, see if that will fix itself automatically. Sometimes biome is a little weird sometimes. And they picked up what we were doing with the register commands, so I'm pretty happy about that. We'll pass in the program as a parameter. So then each of these functions is kind of responsible for defining the command, just like that. Yeah. Okay. So now we can do this for each file. And cursor is going to help us out. Thank goodness. That's some great cursor work. Okay. That's pretty good. That's some pretty good bootstrapping for this repo. Basically lays out the structure. I should be able to run this. If I do bun CLI/CLI.ts, I can see all the commands in there. So it's very nice. Okay, bootstrap repo with CLI. These are always a little hard to test, but I would really love to be able to test this. How can we easily... What is a good way to write unit tests or... Yeah, let's just say tests against a Commander.js program in TypeScript. Yeah, they're basically saying get your CLI definitions away from your yeah, they're basically saying test your functions. Although they do have this integration test sort of thing where you spawn a process to run it. I want to avoid that. It's pretty hard to get that to work consistently across systems. Yeah, okay. And they're recommending spying, which I am categorically against. I don't like spying. Spies are mocks. I don't use them. So we won't do that. Let's see. I think what we could do is introduce dedicated functions. with the name of the directory. Like this. And then we'll call them in here, our functions. So we're basically doing what it recommends. I don't love testing this way. I really, really like integration tests. I would normally spend a lot of time working on it. But I also kind of stopped testing CLIs because of how much time it took to do that kind of stuff. So I'll be a little bit lazier. It's going to make this async. I also kind of want to hint to the AI that I want it to take an object and not like a huge list of arguments. Sometimes it's tempted to do that. Running Chimera takes like a input file path. I think what we'll do we need to have the option to send the results to a repo. But I'm not sure how to control that really easily. I really want to use GitHub for the database on this one. I think it'll make life easier. But it's much easier to test against the file system in the short term. Okay. Just kind of bootstrapping these to that. Input file path 1, input file path 2, defined that interface. Okay, cool. I wonder if we want to, instead of file path 1 and 2, I wonder if we could say something like test file path and then kind of like stable file path. Just to kind of hint that, you know, you want your main branch comparison there. Because we might be able to display things like, oh, you decreased or something if we know which one is the one under test. Probably not the best names, but we'll work with that for now. Let's adjust the README usage here so that's a little bit more clear how this works. I like how it forces a file structure. Let's remove the remote stuff for now. Let's get it working without the remote stuff. Then we'll add the remote stuff. Improved or regressed. And let's say in Markdown. We're going to remove this comment on GitHub thing for now. We'll figure that out later. Local testing of benchmarks, run and compare. I don't know if stable is the right word, but like something like that. I almost want to call it verse. But I think that's what most people would say is the last stable version or something like that. Stable probably isn't the right word, but you have something tested and something untested. I don't know. Yeah, it's a little confusing terminology there. Okay. Whoops. Whoa. test a new benchmark against a stable one. Stable one. Does not output. Does not write. Out. So eventually, I think you would just say stable main or something like that. Or we could even say yeah, I think that's good. It feels wasteful to keep pinging GitHub each time you need a file, so maybe we'll, I don't know, maybe we could use Git subtrees for this and keep this implementation like relatively local only. What else can we include there? Yeah, node version and whatnot. Node version is useful, but I think I'll leave it out for now because we use bun and I don't want to think too hard about how that changes things. Yeah, I probably want to give the CLI a different name than benchmark as well at some point. But that seems pretty good. All right, let's have AI build this thing out for us. So I'll do a work in progress commit. And the first thing we're going to do is get it to fix all of these register files so that like CLIs, you know, all of these register with the correct parameters. So we're going to add the CLI directory. We're going to add the README file. Then we're going to say, please update the register functions to correspond with the README usage. Okay. Oh, it's trying to run stuff. I clicked a little too quickly. Nice. Update the function implementations to have all the parameters. Just asking for small things at first, and we'll start asking for more and more. Yeah, we're not going to run any shell commands. Okay, cool. Yeah, let's format everything. Take a breather. All right, how many steps have I gotten in? I've been streaming for about 50 minutes. 33 minutes of walking-ish. Good enough. Or maybe it was, I don't know, 3.3 miles. I don't know if I could read it properly. Okay, we formatted some files. AI, register, and params for functions. You know what we should call this? We should call this Bunchmark, like bun. Yeah, let's do the build script. So what do we want to build? We could build the lib and the CLI directories because I think we're going to export both a lib and a directory. So let's see if that works. Main will be dist lib index.js is probably what it'll come out to. So it's building every file. Little type error. Just looking at the output directory contents, we have that lib index. So I think the usage inside of the benchmark file themselves so let's say benchmark.bm.json format. So we'll remove that from here. It's kind of nice though to have this. We'll simplify it a little bit. Just kind of add these. Usage. It's kind of interesting because it's a runner. It's a runner, meaning, it actually runs your code. Benchmark run. TS usage. So I think this thing should really just run a script. Yeah, import benchmark. Mark time, mark start, mark end, something like that. There's a lot of ways to do this, but I think this is probably the cleanest way. You say mark end, mark ID. Typical usage. Yeah. So something like that is fine. Yeah, let's start there. Let's start there. You can do basically everything you need to do with that. We'll say mark time. Mark that a function took 300 milliseconds to run. We can also have like FC says, I'm wondering if we can merge the contribution board test in the PCB viewer after you optimize it. Yes. Yes, we can. It's better than the JSON, for sure. So yes, we can. But do keep in mind, we do have the JSON there now. But yeah, we can merge that in. I don't know if we need this. I think these are pretty good for most cases. It would be cool if you didn't. We could just make it so that you can do bun run on these files. Or maybe, Good night, Anurag. Thanks for stopping in. Appreciate it. I feel like I'm over engineering a little bit and I should just go in and optimize the render functions. But the problem is I have a lot of hunches and I've been wrong so much when optimizing on hunches. So I really want to do it right if I can. Yeah. I am worried about the actual running if we introduce this command. I'm worried about the actual running of it. I think we can figure it out. I like this name, Bunchmark. It's pretty fun. Wonder if we can get it on NPM. Let's find out. Yeah, we can't get it. Somebody else got it. Got to it first. I'm still going to call it Bunchmark, though. I like the name too much. But it looks like somebody else has it. It's a good name. Can't blame you. Yeah, and of course it has like 0 usage. Yeah, it's like nothing. It's fine. JavaScript benchmarking library. Oh, they got a whole org dedicated to this. The core benchmarking system. Yeah, how many people have written benchmark programs? AI is going to be so good at this because like it's going to be like, yeah, it's all of this is fucking obvious. But the GitHub integration will be unique. Okay. Have you looked at library bun recommends for benchmarking? It's not going to do. I mean, I asked ChatGPT. I just spent a while asking. Yeah, I mean, the issue here is. Wait, Bombardier, micro benchmarks. A good general purpose tool is Mitata. There's a lot of good recommendations here. Mitata. Oh, output JSON. Oh, this is actually a good idea. It's a good idea. Name. Import bench. I just like the fact that they have a standard output format. It's really all I care about. Yeah, I think, you know what? I think you're kind of right. I think I started, I mean, the thing is, benchmarking is kind of simple. So that's why I started just like writing it from scratch. We should probably combine this with the GitHub features I want. And that would actually be, that's actually what we want. I got a little off track. Um, so that's for micro benchmarks, it says. So we got Bombardier and Oha. This is pretty good. This is a pretty good guide. Good recommendation, name. So this is cool, but this gave me an interesting idea actually. That is interesting. It makes me think, what if instead of having benchmark results kind of output in Markdown, what if they were in animation? Because you can represent a lot in an animation. This is an HTTP benchmarking tool, so I feel like it's not going to be as nice. But there's an interesting idea there too, because we could try to do something like, what if we had our suite serve a server so that we could, it sounds crazy because we're a library, not a server, but what if we pretended to be a server just so that we could use some other tooling that's available for benchmarking? Because I bet there's historical server benchmarking tooling. HTTP benchmarking over time, because we have a couple things like our maintenance tracker, stuff like that, or a status page that measures stuff over time, and these are kind of nice. So if core deployed, I'm starting to get kind of interested in this. If core deployed like a server, if our benchmark suite was a server instead of a command line tool, if it's a server, so you literally go to a page and it runs a benchmark to load the page, you could use a lot of tooling that already exists for HTTP requests. Okay. How can I benchmark HTTP performance for a page and look at it historically? We could build this ourselves pretty easily, but there might be some really nice tooling available. Starting to like this idea. Would be hard to see tiny function difference in the server. I think what I'm imagining, you're right for small functions, but what I'm imagining is, yeah, you're kind of right there. Hold on, let me think about this. Oh no, you're right. No, you're right. Because we need the individual function outputs. It's not good enough to just have one score. We need the individual. I mean, it'd be nice. We could see the performance of core over time, but you're right. No, we need the individual functions, I think. Google Lighthouse, K6, web page test. I don't know. Sitespeed.io. Yeah, they're saying just throw it into a database. Is there any merit to this, having just inserting an HTTP server? Somehow I feel like there's a lot of merit to this. I'm just imagining an HTTP server that returns your benchmarks, and then I can have tons of versions of this deployed because it's so easy to deploy HTTP benchmarks. And also, it runs more consistently than a CLI. And it runs in Lambdas. So you would get, in the case of Vercel, unless you configure Vercel for shared functions, you're going to get like your own Lambda for each one. It's not going to be perfect, but yeah, Vercel makes it really easy to deploy lots of versions. So what if the payload returned from the server had this object that we've sort of defined here? Can't tell if I'm over engineering yet. I might be. So we have an HTTP server that returns these, and different paths give you different test results. And then we can deploy different branches to Vercel preview URLs and see the deltas. I don't know why this is really appealing to me. I think it's because you don't need a database anymore, because you're just always deploying your benchmark. So you don't need to store anything. Vercel or whoever is doing your preview deployments is storing that for you, and you can always redeploy from your Git branch. So the data becomes a derivative of the thing. And then since we have a web page, we could actually have the preview deployment actually show the result of the benchmark. It's not great for GitHub comments. Originally, I wanted a GitHub comment because you could get a comment on your PR that's basically like, oh, there's this much regression or whatever. So it's not, that would be nice to be able to test regression. It's also not great for debugging. Okay, I don't know. That's really interesting. I'm gonna mull this over, but quick bathroom break, about the 1 hour point ish. So quick bathroom break, and I will be back shortly. I am in bathroom. Oh. BRB. All right, I decided this is a great idea. I want to, so we're going to have a server that runs. The server will have two components. So we're going to do a benchmark server. It'll have an index route, links to all benchmarks, and then slash benchmark name. Computes JSON result of benchmark. And I can do a bunch of historical analysis on these things. It's going to be a little bit less general purpose. What I mainly want to measure the performance of is our render functions over time, as opposed to, I don't know. There's a lot of things we can measure performance of. We could do like micro function benchmarking and stuff like that. But the way TS Circuit is built, it basically has all these render functions, and as long as you know the performance of those render functions, you basically have everything you need to benchmark. You could do micro benchmarking, but it might not be committed. We might not track it. There'd be no point. The render function is more consistent over time. So we don't need any of the code I just wrote. We're gonna scratch that. It was good to think out though. So, 1 hour wasted. We thought a lot though, and that's what's important. So we're gonna create a new directory, benchmarks. Say benchmark lib, just to kind of separate it from the lib directory. Yeah. Then we'll have server.ts. Actually, let's call this directory benchmarking. And then we'll have the benchmark lib. We'll have the benchmarks. And yeah. This won't require any dependencies. It's actually going to be pretty simple. Let's start by writing a benchmark. And the server is also kind of interesting. It would be really cool if we could build to a static site. That would mean that the benchmarks are run on Vercel's build servers. So you kind of have two options: run inside Vercel's lambdas, or yeah, that's actually interesting. Run inside Vercel's lambdas, or statically build it. If we statically build it, it's going to be a lot easier. And it's basically just storing data. You're basically just storing your static benchmark data to Vercel servers. Basically just storing JSON data in Vercel. I think this should compute the JSON result of benchmark. Let's say benchmark.json. Let's do this. Just kind of defining out this little piece of software here. shows benchmark comparison against main branch. Yeah. Okay. So we'll build. Yeah, I think we can. Should we build this on the Vercel server? We could probably use Vercel's builder. Vercel builder machines. How consistent are those? I don't know. Maybe they don't share. They don't want you to depend on it. So it's called Hive, Vercel's internal build servers. So basically they're saying we have a box, which is a bare metal machine. And it could be on EC2 or wherever. And then we have cells, which have all these virtual machines that are building things. Oh, and they use Firecracker. I use Firecracker too. That's for FlyIO. FlyIO has it, but it builds Docker containers really quickly. Okay. Yeah. So they're not going to tell us anything about the box, are they? And it doesn't matter because we might not even have access to all the processes in the box. But it's probably a very fast machine. It's probably going to be less consistent than the Lambda. Measuring the Lambda would be cool because you could see if Vercel's machines changed or if the commit changed the performance. Yeah, it's tough without a consistent machine. Benchmarking is always going to be tough without a consistent machine. But you can definitely get the gist of it. This kind of makes me think it shouldn't be deployed to Vercel at all. It should be deployed to like Fly. Yeah, because you can't even really compare. You can't really compare with anything except on your machine. Oh my gosh. I didn't expect this whole stream to be me just mulling over how to do this, how to implement this project. The benefit of deploying it to Vercel, static build or not, is you could 100% show the difference between two Vercel builds. So each Vercel preview deployment can give you the difference between different benchmarks. So that's good. But it's not going to be super helpful for local development. Our other tool, our CLI tool that you run locally, would have been better for local development. The other option is this feasible? What if you sent... We could have I don't know. We could have a build server... We could have a benchmark server, so it's always the same server, and you send your code to it. So you build, and then you send your code over to it. But that seems really complicated. And then that guy has a database, and then we want that database to be in GitHub. And so we start doing full circle. I don't know. Maybe the CLI is best. Hmm. Maybe the CLI is best. I don't know. Hmm. All right, I don't want to ponder too long on stream. I feel like I'm not making a lot of action. It's probably not very useful. It's mostly in my head. Uh but I also don't want to build aimlessly. So I'm gonna go to the drawing board. I'm gonna think this over, and then when I have an approach, I will come back. But it's hard. I can't really decide. I don't even know really how to validate which approach I like the most. Um, yeah, there's trade-offs to every single approach. I kind of like the idea of sending your source, so you send off your built source file to a server. Are there servers for benchmarking? Like dedicated services? Hmm. Here's another interesting idea. The benchmark server. Ooh, I did this kind of weird. Yeah, cool. The benchmark server actually hosts the source code too. So it has the library built into it. So the reason this would be nice is theoretically you could pull from that server that particular version and run it. Hmm. Man, I think Vercel preview deployments are the easiest option. Each Vercel preview deployment has the benchmark results. It compares against main, which is always going to be another Vercel preview, and you just cannot test your benchmarks locally. And this way I can do historical tracking. I could very easily make a status page that tracks the how fast the render time is over time. And I feel like that's most important. Just to understand if we're getting slower or faster, and what made us slow or what made us fast. I feel like that's most important. Testing locally, like, yes, it's important, but maybe we only write like one benchmark, and then we're basically pushing to Vercel to get a consistent machine to compare anyway. Like, if somebody says, oh, this got 50% faster on my machine, I'm not going to really know if they even designed, like, if it's machine specific, or maybe they didn't run it properly. So I don't know how much that local development factor is really important. But is there any way to make local development possible? I like this idea of having like your branch, and then you can access the benchmark of that branch. And that would enable local comparison, because you could store historical branch benchmarking. Yo, what up, Manjeet? How's it going? So we could do this. Now you have access to your historical data. It just needs to be like stored somewhere for your system. It can't be generated on the fly. All right, I have a fucking nuts idea. But instead of that, we could do /builder or something like that, or dist, whatever. And it uses, you can have two versions of TS Circuit locally. So you're inside of TS Circuit Core. There are like two things you could have. You can have the built version inside the dist directory, or you can have the TS version that's run by Bun. We run the unbuilt version. We test against the unbuilt version. So theoretically, a build issue could break our tests and we wouldn't necessarily know. But we can use this to our advantage by saying, okay, how does it compare with the version in the dist directory? In fact, you could take it a step further and screw just showing it. We could literally always benchmark against it. So instead of against main branch, it can go against main branch or distdir. So if you're running it locally, it would go against the distdir. Good for local development. And that's how you can have your kind of main branch still kind of there. Because the build directory is going to be optimized, it's probably not going to be perfect. But I think for the most part, it should be roughly-ish the same. It's not great, though. Yeah, the only real solution is to run an old version of the benchmark server locally. Yeah. Using remote or second benchmark server. Yeah. So basically, if you want to compare it, you have to have another benchmark server running with the old version, or you can run it against your distdir, which is decent for local development. It's okay. Not a perfect comparison, but it's okay. I don't see a better way to do it than that. So that's gonna have to be it. This kind of sucks though. Yeah, I can't think of a different way to do it though. Unless when you run the server, it like copies your entire TS circuit directory, undoes all the changes, it fetches main. So it could, I mean, maybe this isn't that crazy. You could, I don't know. This is nuts, but you could copy the library directory to a temporary directory. And then revert to main, import for a stable benchmark. That's a lot though. That is a lot. There's also like the node modules directory and all of that you have to deal with. So it's actually going to take up a lot of space on the user's computer. So I think this is kind of crazy. All right. All right. All right. Let's do it. Let's write some code before I talk myself out of it. So benchmark 1, we'll label these benchmark 1. Let's do LED matrix as the first benchmark. I don't even know if we need this benchmark TS thing. Might be okay. Let's do export. Yeah, I don't know if we need it. It's kind of obvious. We'll make it a TSX file, and we'll just export a core component from it. Do we even need the root circuit? We could just export a component. I don't think we need anything. So we'll do board, width 10 millimeters, height 10 millimeters, and we'll just kind of create an LED matrix. LED matrices are maybe a little bit hard to create. I don't know. Let's there's a cool function inside of TS-Circuit MathUtil for creating a grid, so we might as well use it if it's available. It's not up to date, so let's update that dependency. Get our grid function. There we go, grid. So we're going to use that grid 10 by 10. Sure. Oh yeah, great. Love it. We can also add a bunch of stuff. So we can do rows, we can do columns. We can also do X spacing. So we can say we want 2 millimeters of spacing between each LED. And then in addition to the LEDs, we'll want to create traces. Let's import fragment from React. Yeah, I'm just thinking. I feel like I'm being swamped with errors right here. Oh, I don't know what's going on. Is it formatted properly? I feel like it's not. Property X does not exist on grid cell positions. It's probably like center X or something. Center, okay. Actually, what else do we have? Do we have row and column here? We have index, all right. So I can say LED name equals LED index. I've heard some people in the UK call LEDs LEDs. I've heard that before. Madness. This should really have row and column too. I'm a little disappointed I don't have that in the method signature. I might just throw that in real quick. If we go to the MathUtils module, go to the grid function. Yeah, so grid cell positions, we can do row number, column number, and then we can just add that to the output down here. So row, column, boom. Little PR. Okay, little PR. Let's jump back to it. We're not going to have that available right away. But anyway, could probably keep this pretty simple. So we can say from LED name. So there's a anode and a cathode. But I like to just use positive and negative. So we'll say that goes to net.vdd. We can add a resistor per LED too if we want to be kind of realistic. That's generally how LEDs would work. There'd be maybe a 1K resistor on each LED, prevent it from exploding. So we'll say positive goes to VDD. Oh, this resistor also needs a name. So we'll say resistor name. The LED negative is going to go to the resistor positive. Then you're going to have the resistor negative go to net ground. So a small circuit per LED, but since it's a 10 by 10 grid, this is actually quite large. So this is a pretty decent benchmark circuit. There's a lot of traces. There's a lot of things to connect. Yeah, we could throw this into TS-Circuit snippets and see what it renders out to, just to make sure we're not being completely crazy right now. Although I think that grid function isn't available. I don't think you can import TS Circuit math utils. I've been meaning to fix that, but unfortunately I have not fixed that yet. Let's see how far we get. Maybe it works, maybe it doesn't. Yeah, grid is not defined. And then if I import grid from TS Circuit / math utils, it probably won't have it there. Right? Yeah. Okay. Yeah, imports available. Those are all the imports I have available. So I've been wanting to add that to snippets. So let's go ahead and do that. We'll do a couple quality of life PRs. It's kind of good to just do those as they come up. Otherwise, you'll forget because they're so minor. And I would create bounties for it. Something I want is a stream bounty system where I can just say like bounty and it'll bounty off an issue or create issue. But I don't have that yet. So instead of doing that, we will just manually implement this feature, which should only take a minute anyway. So I'm going to look for TS Circuit Core, which I know is already imported. So maybe we can figure out how this runs from that. Pre-supply to imports. Yeah, there we go. So pre-supplied imports, TS Circuit Core. It looks like we're giving some imports. So we'll add math utils to this list of imports. And then we'll go to the top, import star as TS Circuit math utils from TS Circuit math utils. Also update to the latest version. Actually, just want to check. I'm just going to revert that update very quickly. Merge with main first. And then we'll redo it. That way we don't have to deal with a merge conflict. Add math utils as a pre-supplied import. I don't know if all the types will work. Maybe they will. We'll create a PR for that. This one I should probably test. So I'll open up Bun. Or I'll open up our dev server. Do new, blank circuit board. Paste in that circuit. Run. It says fragment is not defined. So fragment you have to import from React. That's fine. I don't know why I didn't copy that line over. Cannot find port for selector LED 0, position 1. So right now we use a CSS-like syntax, so I have to put dots here. But we'll probably get rid of that eventually. Could not find port for selector LED pause. I don't know. Hey, super cool. Cap. What's written on that? Is that the TS Circuit cap? This is the TS Circuit hat. Yeah. We got Chippy. The logo of TS Circuit. Chippy. I know it's possible LEDs don't have a positive trace, so let's see if that gives us progress. It's saying it doesn't even have a pin 1. Something tells me that's not right. Let's try changing the name slightly to be a little bit more conventional. Maybe the dash isn't supported. Oh, page is breaking. Well, I'm glad I'm testing this. How can I get that? You could get it during Hacktoberfest if you made 10 contributions. Yeah, I think you had to do it during Hacktoberfest. But you can still get it from the TS Circuit swag store. You'll probably get it after some number of... next time we do a promotion, you'll be able to get them again. We do have TS Circuit merchandise. I mean, we might add more in the future, but, you know. I think we have to be more popular before we really focus on that. You don't want to, like, drink your own Kool-Aid if you're not cool. You see what I'm saying? You have to be cool before you drink your Kool-Aid. After you drink your after you're cool, you can drink your Kool-Aid. So to speak. I'm wondering if we have a bug with LEDs. So I don't know why the circuit would not run. Import React JSX runtime is not found. Can I import from React? And that completely freezes it. It's very strange. I don't know where it's freezing it. I have more than 55. Just kidding. Maybe next time. We're gonna run more promotions, and so you can get one when we run we run our next promotion, which will probably be soon. You won't be waiting that long. Don't worry. You won't be waiting that long. Okay, so interesting that that's broken, but I think it might be more related to the fragment than what, anything else. So let's try it without the fragment. You don't have to, when you're using fragments in React, you don't have to import from React. You just not do that. And you just use the syntax where it's kind of like that. But the syntax doesn't allow you to key it. So you're really not supposed to do this, but I'll try it. But it's still crashing. So I don't know. Kind of seems like a bug. Endless bugs. Okay. Well, it's disappointing. So if you do this, you just have to give key properties to each of these. You know what we can do instead? We can use a group. Okay. I wonder if that'll fix it. I don't know, I'm kind of just messing around. It freezes my browser every time, which is really annoying. Okay. I also wonder if it could be this grid function. Since that's kind of technically a new thing as well. Yeah, it's still freezing up. I don't know. Let's create a test for it. Oh, I just realized with 100 LEDs and not routing disabled, it might legitimately actually just be a performance issue. Let's try reducing it. Just 2x2 or 3x3. Should be able to handle a 3x3. It might legitimately just be a performance issue. I didn't consider that. Yeah, it was a performance issue. Wow, huh? Yeah, because it's trying to use the TS circuit autorouter. This doesn't look as good as I thought it would. So let's increase the X spacing and Y spacing to 5. Yeah. Oh, wow, it fully routes. That's pretty cool. That's the TS circuit autorouter fully routing that board. Not bad. Okay, I guess I can close my issue. It's just a performance issue. The 4x4 almost never renders. Wow, that's crazy. That's all from the the PCB auto routing, but it actually successfully does it, which is pretty cool. So the auto router works. It's just yeah, it just takes a little while. Oh, I guess this. Sorry, I'm really mucking about on this. Let's disable the routing temporarily, and then just get this spacing right. Also, LEDs typically aren't in an 0402 package, so we can adjust that. And then instead of doing +1 for the X, let's do -2. Just give it some space. Yeah, that's a little bit maybe more conventional if you were going to do this. We could also make this circuit maybe a little bit more realistic if we added a header, a pin header. Say J1, pin count. We'll do, let's see, how many LEDs do we have? We have 16, so we'll do 16 pins, maybe 17 to include ground. Or, actually, these just connect to, you have a PR on easy EDA converter. Okay, cool. I'll check it out. All right. Anyway, that's our benchmark circuit. Okay, we're gonna add our benchmarking circuit. All right. Z-axis rotate. You got to get better PR titles, man. Z-axis rotated 180 degrees. This says nothing about what you did. Z-axis rotated 180 degrees. I don't know. I don't even know what this fixes. I don't know why. I don't understand any of this. What does it fix? How many boards does it fix it for? I feel like we need 3D snapshot testing to really know if we're actually fixing these issues. And 3D snapshot testing is not easy. I think I could build 3D snapshot testing, but it would take a full day. And I don't know if it's worth it in the short term to do it, because I think it would take one full day to build 3D snapshot testing out. And then it would be a solved problem, but one day of time is not cheap. All right, we got our benchmark circuit. Tested it. We're going to have a server via bun serve. So export const start server. Yeah. We'll pick some random port for this. Okay, so there's two types of requests we need to handle. Let's make a directory server endpoints. We'll say index. We'll say home.ts. And then benchmark file. We'll export route handlers from this. Handle benchmark file request. You could also call it request handlers. Whoops. We'll do the home page first. So we want to return an HTML page from this. We can import from React DOM render to string. Like that. The issue is when I import some JLC PCB imports, it rotates by 180 degrees sometimes. Sometimes it doesn't seem to rotate, right? So you just have to you have to find some way to prove against the samples we're importing that you're correct. And one way to do that is snapshot testing. I think without 3D snapshot testing, you're not going to be able to do it. And so my recommendation would be to implement 3D snapshot testing. The only way to implement 3D snapshot testing right now is, I mean, there's a couple ways to do it, but probably probably the easiest way is to have a server run a headless browser against the 3D viewer and have a small database for handling circuit.json uploads. And or rewrite the entire 3D viewer, write a version of the 3D viewer that renders the SVG using, I don't know what libraries. There's some Rust libraries for that will work for rendering a web page, a canvas to an image, and so you could use that for the snapshot testing. But yeah, I don't know. It's really tricky. Yeah, and especially the fact that circuit.json is so large that you can't really send it in a lot of payloads. You could. I mean, if it's usually less than 5 megabytes for snapshot testing, so you could have a Vercel server that renders a 3D view to a PNG. The main problem is when this part comes from the object UUID, sometimes its rotation offset will be 0 or 180 degrees. Yeah, I completely understand that, but I don't know that you're fixing anything. I don't know if you're fixing it just for your parts or if you're breaking other parts, right, Ansh? You could be breaking many other people's parts. So you have to validate that you're not breaking other parts by doing snapshot testing for the 3D view against a lot of parts. And then we know that you're not breaking it. But based on your fix seems nonsensical. Your fix does not seem, it doesn't make any sense. You could break it down okay, what is RZ, right? It kind of seems like you just hacked a variable change. So you're probably breaking other things. Somebody wrote that code originally for a reason, right? They thought about that rotation a little bit. They probably weren't trying to import things backwards. So you're probably breaking at least one component, probably many components, right? So snapshot testing is probably the only way you can verify. I can't think of a way you could prove without snapshot testing that you're not breaking stuff. It's not that hard to circuit.json 3D snapshot server. To create a 3D snapshot server, so that you can get snapshots. Or you could do it without a server. You could try to get it to work locally, but I think it would be too heavy. You could try to get it to work locally too. I will add a test for snapshot testing. How are you going to do that though? There's no way to do 3D snapshot testing. Yeah. You have to create a way to do 3D snapshot testing first. Like you could look up Three.js headless rendering. Yeah, not a lot of people have a way to do it. You have to use a headless browser. You can use Playwright. Puppeteer, I don't know why. You just use Puppeteer. Or sorry, not Puppeteer. What's it called? Playwright. Because I think this is a little bit. Some big companies got behind Playwright, so seems to work pretty reliably. Well, people do have headless WebGL, but it's not very popular. I can't think of a really good way to do this completely locally. It's probably going to break everything. The thing is like running a. Yeah, so Ansh, you could write Playwright tests that take a screenshot of each output, and that would work. It's really, really kind of intense, but that would work. Yeah, it's a little complicated to set up, but basically you have Playwright running inside of the Easy EDA converter for testing. And then it loads the generated the 3D. Yeah, it has to load in the converted circuit JSON into the 3D viewer somehow, and then you take a screenshot of that. And then you do that for a ton of components until you show that you've loaded the 3D components properly. That's probably the easiest way. It's just to do it with Playwright testing. We could build a server that does 3D snapshots automatically, but Playwright testing would be more reliable for local development. So Yeah, you'd literally have to introduce a server to the Easy EDA. You know, it's actually not too bad. It's actually not too bad. If you know what you're doing, you just add Vite. Touch a Vite config. Bootstrap a Vite index.html file. Instead of doing /source main tx, we'll do /site. Bootstrap a Vite main.tsx file. Create an app. It's complaining because we don't have React. This isn't a React project. Let's just issue, yeah, okay. Always good to load in the Tailwind CDN. And we'll call it the page title, Easy EDA. Okay, so now we should be rendering a website. Yeah, so we're rendering a site now. So now you can add the tscircuit/3D viewer. And then in the app TSX, we'll say, we'll get the file name out of the URL. Or the JLC PCB part number. I forget how to parse URL params. Parse JLC PCB part number from get parameters of URL. Okay. And then if that works, we're going to render the 3D viewer. We need to get circuit JSON. That's important. So to do that, we'll import from the lib convert, what is it? However this works, convert, what's the usage of this library? We have to fetch it and then convert it. Okay. So we'll say easy or circuit JSON. Or I guess you want to actually run the maybe instead of using a 3D viewer, we use let's remove the 3D viewer. Let's use run frame, because I think you want to actually run the TS circuit code to make sure that the CAD component has the right stuff in it. So TS circuit slash run frame. So we'll say TS circuit code, set TS circuit code. Then we'll do a use effect. And we'll go through the whole process of converting this into TS circuit code. So this is what it says to do in the README. So we'll just copy that and hope that works. Okay, so we're going to run this use effect. We should also have an error state. There's a lot of stuff to do to set this up, but it's all easy. So when we start processing, we set the error to null. And then we do convert parts. We set an error if it fails, but otherwise we have the TS circuit code. And then we'll render out the component. So to render this code, we need to set up the file system. So TSX, TS circuit code. Yo, man, your speed of typing. Thanks. And then we need an entry point. Okay, so a little bit weird, lots going on, but that should be the setup to run TS circuit code in a browser for this project. We also need to set the entry point file. So maybe that works. I don't know. Let's find a part. C57 blah blah blah. Okay, so this is a part, I guess. So let's do bun run start. Dependencies could not be resolved. Lib. So Vite doesn't like to resolve dependencies the same way that JavaScript does. So you usually use a plugin called Vite tsconfig paths. And you'll see this in basically every config. We have to install some dumb thing for dumb reasons. No matching export, blah, blah, blah. This is probably because circuit.json is out of date on this repo. Okay, this is probably because circuit.svg is out of date on this repo. So a lot of these are peer dependencies, so you run into these issues, but it's a real pick your poison situation. All right, so when we reload this page, it should display, hey, you didn't put anything in the URL, but it looks like it errored instead. It says global is not defined. So another problem with Vite is it doesn't know what global is by default. So usually people just do something like this. Global this it knows about. Global is technically like a Node.js word. There's a lot of history behind that. Okay, now I'm having an issue because this is a known bug with TS Circuit. You have to use React version 18. And this is something we really want to fix, but unfortunately it has not been fixed yet. Okay, no part number provided. Add JLC PCB part number to the URL. So now we should be able to do question mark JLC PCB part number equals, and then we can paste in some part number. So I'm just going to open up some random file and copy the part number out. C16. I don't know what this is, but hopefully this displays. Okay, so it displayed run frame, but it says file snippet.tsx not found. Let's see, access to fetch. Oh, okay, it's not working because of CORS issues. Yeah, so that makes sense. The Easy EDA API is not going to support CORS. That's cross-origin request sharing or something. So it works in Node because Node isn't subject to CORS restrictions, but it doesn't work in browser because you are. So how we can fix this is we can say to the AI, create a Vite plugin that handles requests to /API by API. Let's say that handles JSON requests to API with a body of JLC PCB part number and responds with TS Circuit code as shown in the app. Okay, so we're gonna try to port this code to be a Vite plugin on the server. Okay. So whenever you see this chunk stuff, it seems really complicated, and it is, and that's because Node.js's default HTTP servers is pretty lame. We're gonna anycast this error so that we don't have a type error there. Looks good enough. So now we'll say adapt this use effect to use the API server created in the Vite config. So now, because the Vite server runs on Node, we should be able to get around CORS. Yeah. Okay, let's try again. I think I typoed. No. Snippet.tsx. TS circuit code. Yeah, we sure need an AI tutorial. Yeah. Wait, do you mean the TS circuit AI or what? Like a tutorial on how to use it? Like with cursor? Probably not, right? I think it's pretty relatively clear. For some reason, this post request here, I think we're getting some false errors here. So if not TS circuit code, we're gonna say loading. Yeah, so now it gets stuck on loading, which is fine. It's saying the API is not found. I think I have to restart the Vite server. Oh yeah, there we go. Okay, cannot find package lib in our Vite config. It's because Vite is very stuck up about tsconfig imports. I feel like that shouldn't be happening anymore. Oh, it's because the other files import lib. We could try to... It's a hack, but we could try to import it from the dist directory temporarily. Cannot resolve dist. Oh, sucks. Oh, actually, that's fair. There we go. Yeah, okay. Element type is invalid, and we can't see the code, so that's kind of annoying. So we're going to adapt run frame to show us the code by saying show, by saying... Oh, man, it doesn't expose the properties to show the code tab. I was talking in general, talking to AI like you do is really good. In my case, I'm getting better, but sometimes it drives me crazy. Yeah, it's because I kind of already know what I want, and I'm just helping it along. So I think that's part of it. Man, it really sucks that Vite won't handle all those lib imports. I can't think of any way to fix that. Any easy way to fix that. Other than refactoring the entire app to never use lib. Oh, actually, is it just this one file? No, that file's not even used. Oh. Wait. Oh, it's just this file that uses lib. Because it doesn't use lib internally. It's actually kind of weird that it shouldn't even be using lib. Oh, no. There's tons of lib slash, so that would cause problems. All right. It's fine. That's a bad import, but it's fine. Yeah, fair, actually. Yeah, it's like I already recognize. It's just from lots and lots of repetitions. All right, we're going to modify run frame to allow you to set the code tab content. It's supposed to allow this, but it doesn't. So yeah, show code tab content and then code tab content. I think the reason run frame doesn't currently show it is technically it's able to show you all the code. Maybe we shouldn't. It's technically able to show you all the code, so maybe that's why it doesn't. That's kind of fair. Let's try this again. All right. What I'll do is I'll display run frame on the bottom, or I'll display run frame at the top and I'll display code at the bottom. So we'll put in a div here, and we'll display the TS circuit code just so that we can see what code is actually causing this issue. We have to escape this code. Code format to look like code using Tailwind. Make sure characters like, you know, I think React automatically escapes it, so it might be okay. Let's try it. Yeah, so now we can see the code at least. So it's complaining about this. It says element type is invalid. I don't actually see an invalid element type though. Oh, I know what it is. It's because there's no default export. Let's do import star as snippet from snippet.tsx. Likely. And then let's find an import. Say key. Any key that doesn't start with use, so it's not a hook. And then we'll render that as a component. So we'll say const component. Yeah. Okay, let's try that. Invalid props for chip unnamed. So we have to give it a name. Hello, brother. What up, Parvez? Welcome. Invalid props for plated hole unnamed, inner width, inner height. Both of these are required. I guess this component might actually be broken because that actually sounds like a pretty legit error. Also, the new loader, interestingly, displays where it got hung up, the render phase where it got hung up. I've never seen that quote unquote feature. It also displays loading even if the thing crashed. But that feature is pretty interesting. Very handy. Surprised we didn't have it earlier. Glad we have it at all. Okay, let's just pick a different component. Okay, C148 something. See if we can get this one to render. Component is not inside an opaque group. No board. Okay. Fair critique. They want us to put the component in a board. That doesn't not make sense. So we will oblige. Okay, cool. So now we're rendering. We can see all the code down here, and we can click on the 3D tab, and we can see the thing loaded. Anshu, are you still there? This is now you got to write playwright tests against this, and then you can prove that the rotation is correct. I don't even know if the playwright test will be consistent because you can't turn off this rotation. I don't think you can turn off the rotation. So we need to make it so you can turn off the 3D viewer rotation. Otherwise, the diffs won't be consistent. I don't think you can turn it off. Auto rotate. I would actually be like a little bit mind blown if you couldn't turn it off, because it's such an obvious. Okay, CAD viewer. Wow, I don't think there are any properties to this. I don't think you can turn it off. We have everything to make the 3D snapshot now. I just have to bootstrap the tests. Also, I mean, we already have Circuit SVG, so we don't need previews of these. But you can preview other things. But yeah, this is working. So now we have a server. You can put in any JLC PCB URL and get the component. So you can use that we can use this for snapshot testing because we have a server. We can write playwright tests against it. But I think Ansha's gone, and all this was for him to write, for him to take it to the next stage. So let's create a branch. We'll call it playwright. The 3D viewer needs to have a prop to make it stop rotating, make it not rotate. So disable rotation with prop rotation disabled, perhaps. Maybe auto rotate disabled. So we have to initialize playwright tests. I forget how to initialize playwright tests. This is something I don't do as much as bootstrapping a Vite server. I didn't know about this playwright show report page. That's pretty cool. It also shows performance page render. Speaking of displaying benchmarks. Okay. Installing playwright. So we've installed it. Do we really not need a config file? I think I have to install playwright test. Oh, it's annoying. So much configuration. But basically, this is the gist of it. So you do every test is going to look like this. You go to some page, you take a screenshot. That's basically it. We want to make the default view the 3D view. I really hope I can do that. Default active tab. I don't know what it's called. Let's see. CAD. Okay, so now the 3D view will be the default view. Ooh, it doesn't work. Oh, are you kidding me? Oh, there we go. Okay. I don't know. Maybe it was cached. Okay. So 3D view is the default view. So you just have to so you just go to this page, you take a screenshot. That's the playwright test. Eventually, we're going to have to disable rotation on this so that the screenshot is more consistent. But that's it. We have to write a playwright config so that it starts the Vite server. Just assume nothing works by default and like life is unpleasant but predictable. So we're going to open up the playwright config, Define a playwright config that boots up Vite. It's actually pretty good. It's kind of nice to not use the Vite port when testing. Like to use a slightly different URL, like, you know, I don't know, 5181, something like that. That way you don't have conflicts if you want to test out the development server at the same time or something. So we'll do that. Also have to adapt our test. Okay, so now we should be able to do playwright tests. Do we have a bun fig? We also have to tell, don't run test files in the playwright directory. I don't know if that works. Oh, it doesn't work. We can adjust our test script. Ah, it's junk. It's going to try to run. It's probably going to try to run the playwright test. Yeah, playwright test did not expect. Bun exclude directory from testing. Oh, okay. So we have to adjust bun test to run bun test. Oh my gosh. Let me see if I can change tester playwright test extension change. I'm sure other people want to do this too. How can I give playwright tests a different extension than .test.ts? Oh, spec. Perfect. Okay. All right, let's see if we can run playwright test. Should I put a screenshot somewhere? Did it run? Bunx playwright test. I think it's getting stuck on hitting the server. Reuse existing server. How do we do this in snippets? Vite config. Yeah, there we go. So somewhere we start a Vite server. Server. Ooh, how does this start a server? Oh, sorry, not the Vite config, playwright config. Oh yeah, it does the same thing. Except it uses npm. I don't know if that changes anything. We can try it. Shouldn't matter. It's just running Vite in the background. Oh, it's starting on the wrong URL. See if that adjusts the URL. There we go. Okay, cool. And then Playwright automatically opens up this test report, apparently. Browser type launch executable doesn't exist. Chrome headless. Run Playwright install. Okay. Bunx Playwright install. So I think it needs to download a binary for Chrome or something. Okay, let's try again. Waiting until load. What happened? SSL protocol error. So my test, or my spec, as we're now calling them, needs to be HTTP. Okay. A snapshot doesn't exist. Writing actual, and then it gets stuck on this loading thing. So maybe we need to wait until network requests settle or something like that. Wait. Let me see. Oh, there's something like wait for network. It's like wait for network idle. Let's see if this works. Okay, we're passing. Let's take a look at this screenshot. Screenshot still shows loading. We don't like that. We also want to wait for the CAD component to actually load. So it's kind of a tricky situation. Let's say wait for loading to disappear. That's the first stage. Okay, state hidden. That's not really going to happen. It might hang on that because it doesn't get hidden, it just goes away. Oh, it did work. Oh, look at that. It worked. Oh, but it timed out. Oh, you know what we could wait for? We could wait for the code to be populated. Oh, we can do whatever we want, actually. We have app.tsx running this state machine. So let's say ID, code content, wait for ID equals code content to be displayed. Wait for all network requests to complete. Okay, let's see if that does it. Okay, so this error, it's saying failed to take 2 consecutive stable screenshots, and this is because of the auto rotation. So yeah, you can see it's literally failing because of the auto rotation. So we need to turn off the auto rotation. So I'm going to commit all this, but somebody has to do that next step of introducing those props. Otherwise, we can't have stable 3D viewer tests. So 3D snapshotting via Playwright. And then we also need to run the Playwright test on CI. I don't know how we do this. I'm going to copy over whatever workflow we have in snippets because I haven't really thought about this in a while. A Playwright test. Oh, it's ploppable, so we could just plop it, but I'll do it manually. Yeah, seems okay. Well, that was a diversion, but 3D rotations, now you know, we can try to figure them out. And we have a pattern for 3D snapshot testing. This doesn't work until we disable the auto rotation by the 3D viewer, because subsequent snapshots aren't stable. We use the Pico. We use the Pico. I have lots of Raspberry Pis, but we primarily use the Pico. The Pico 1. I like the Pico 1 because it uses the RP2040, which is cheap and abundant. But the Pico W as well. But we have a lot of Raspberry Pis. All right. Looks like there's also some kind of type test failure. I don't know why the types are failing. Oh, it's because the Vite config imports dist. That's pretty funny. Yeah, that sucks. We can tell the TS config to exclude the Vite config and see if that makes things less problematic. Choosing female pin headers. Why are you choosing female pin headers? The Pico uses pads. Female pin headers. Pico uses there's no holes. No holes on the board. You just place it from JLC. You don't have to worry about holes. Also, the Raspberry Pi typically has male headers on it, so you would want to the chip uses Raspberry Pi GPIO. Yes. I don't know what you mean. The chip uses Raspberry Pi GPIO. Do you mean, are you talking about the screen? The screen uses Raspberry Pi GPIO? Of course. Of course. Uses the Pico's GPIO pins. Probably uses the SPI bus. So you probably want to give it the access to the SPI bus. This is a Pico pinout. And these are labeled. If you use my Pico, I have all these as pin labels. So yeah, you just connect it. You don't need any kind of female pin header though. Unless you're talking about the if you're talking about connecting it to the back of the screen, which I still recommend against. If you're talking about connecting it via cable, you can just use a standard 0.1 inch header and it should probably plug in. I still haven't found my ePaper screen, but I kind of like plugging it into the board rather than having, because I have like a bunch of boards that have wires hanging out everywhere, and I get that it's more flexible or whatever, but like I have so many boards like that at this point. Oh, by the way, I found it. It was in this box that I had all along. So I have the exact cable now. So this is the cable. And like I wouldn't use this connector. I kind of hate this connector, to be frank. It's going to take up a bunch of time. The end of it uses all of these 0.1 inch headers. These are 0.1 inch headers, and I have to carefully plug in each of these individually. So it's like just like using that big black block and using male pin headers would be better. I have a 2.9 inch on me, but I'll I'll buy tons of these. I don't care. Those things are really hard to plug in consistently and all that. Oh, interesting. Module for Pico. They have a Pico module. That's cool. You could literally look. They might have a schematic for this, for the Pico, for how they do it. But yeah, like, if you're not plugging in direct, like, it just makes everything harder. You have to, like, have multiple mounting points. I don't know. Wait, does this even have? Oh, you know what? I'm full of shit. Oh, I'm kind of confused. Do we have a SPI connector? A SPI is not a connector. SPI is a protocol. SPI can go over any type of cable. SPI can go over any type of cable. So a SPI connector doesn't make sense. SPI female header and screen connector. Okay, this is the module I have. It actually only has a JST style port. It has no headers on it. But I'll buy it. I can buy a different one that has headers. But yeah, this one doesn't have much. Let me see if I can sorry. I'm gonna try to do some zooming. I think I have a couple of these screens. I don't even think this is the only one I have. But I'll just buy whatever, so it doesn't really matter. How's this work? Is that upside down? Why is it all upside down? This is very upside down. Huh. If we just want yes, an e-paper hat, but you don't need a cable is what I'm saying. Dude, I cannot figure out why the screen is upside down. Let's do this. Let me turn this off and turn it back on again. Okay, I broke it. I don't know what I did, but OBS is now banned. To add it to the camera? Oh, geez, wow. Yeah, I really shouldn't have pressed whatever I pressed. Anyway, yeah, that's not the one I have. I have a 2.9 inch one. 2.9. But it doesn't matter, because I'll buy whatever. I have a 2.9. So it has this connector. I like the one you have, the 2.15 one, because it can plug directly into a board. But I don't want to deal with these cables. Another reason to not deal with these cables is, like, it's not going to show up in the 3D preview or anything. I don't know. I mean, I guess either way, we're probably not going to be able to get it to show up in the 3D preview. But I hate cables. Especially ones where you have to carefully wire. If you actually selected the cables properly, where I wouldn't have to, where it wasn't a fly wire with all those disconnected cables. Yeah, exactly. If you make this connect to the header, if you make this black thing connect to the headers of the Pico, that's preem. That's great. They also have a raw display option. Oh, that's interesting. $6, you get a raw display. So that's the display without the driver. Look how complicated that driver is. It looks very complicated. Yeah. I think when people get serious, yeah, this is basically what I want, right? Is it just plugs in like that. So we do that, and then it's going to be really easy to stack up like 20 of these. Do you see what I'm saying? Like that's going to be easier to stack up than if there's a bundle of wires everywhere. I don't know. It's open-ended, but at the same time, like if it's really high effort, like if I have to plug in a bunch of cables and the cables get like the other thing with cables is I have barely any storage here. So if there's a ton of cables, I won't be able to use it just because I'll have to take it apart. It won't stay together. But if there's no cables, it'll stay together. One more thing, the Pico headers are not double headers, single headers on each side. There are no headers on the Pico. There are no headers on the Pico. Like you can buy a Pico with headers, but see this Pico? It has no headers. Right? It has no headers. So you create a board that has the Pico and then has male headers that you can plug in the display. And that would be our test e-paper display board. So you place a Pico and then headers, male headers, then you plug in the e-paper display. And that would be a test board where we could test to make sure that we can drive an e-paper display. And then we could make a bigger one, right? We could stack these up. And how much is this? This thing is like what, $10? I can't even tell. Oh, that's their price tag module with cloud platform support. Yeah, this thing is that's kind of confusing. How much is it? Why are they displaying two prices? I would like to use the biggest screen that you can plug in with headers. That's my ideal case because I don't want to have to plug anything in. But I don't know. I don't know how big those get. Anyway, if that's it's probably $16. My guess is the one with all the components is $16. This is e-paper hat plus G. There's G and B. I don't know what the F is going on there. It looks like there's a couple variants. Wherever you see oh, whoops. I'm not even sharing my screen. Sorry, I'm staring at this stuff. This is funny. Segment e-paper display? What? Is this real? $91 segments. Wait, this is so cool. It's really small though. 91 segments for temperature. Wow. Huh. That's pretty cool. That is very single purpose. Yeah, the price gets really high as you keep going. And it looks like most of the time when there's a module, they just have a cable. They don't like to put on headers. They like to have these little JST things. So I don't know, maybe we need to figure out, maybe we do need to not be lazy and just figure out how to use this thing. Because it looks like that's like the common interface. I have one here so I can take any measurements that we need. All right. Maybe we do need this cable. I know I just ranted forever about it, but they're so friggin' annoying. I hate cables. All right. It's the whole reason to use TS Circuit is to avoid cables, you know, to get a PCB without any cables. Okay. So I definitely don't want to use this cable. If we're going to string together a lot of these displays, though, we might want to figure out whatever that is and then find a JLC PCB port that has this. So they say that this is a 1.25. I can see it from every angle now, so I know exactly what it looks like. So these board-to-board connectors sometimes are manually crimped, so people will create these themselves. But then you can usually buy the cable type in bulk or something. So it's pretty annoying for prototyping. It's okay. It's just okay in every way because you can crimp them yourself if you're prototyping. But I don't want to freaking crimp cables. I hate cables. But yeah, it kind of sucks that is kind of the universal interface. You can see my snippet. I wish I could do like Restream, like supported domains so that anybody could link to TS Circuit snippets or GitHub. Is that what snippet? Is it? Did you find a P1? Oh, did you find a JLC part? Oh, shit. Okay. Yeah, that looks right. That looks the same. Is that 9-pin? That's 9-pin? 1, 2, 3, 4. Yeah. No, I think that's it. You found it. Nice job. I think you found it. How in stock is it? Oh, it's pretty in stock. 75 isn't bad. Yeah, it's awesome, man. Nice job. Wow. So now we just need a cable. Right? So we need a female. All right. You did good work. I'm sorry. I was like, oh, just give me something to plug in. That's pretty good work. All right, let's find a female-to-female connector for 1.25 millimeter JST. I don't know what it's called. 9-pin. Forgot the 9-pin. There we go. Oh, it's only one side on this one. Why on one side only? There we go. I would love if I could get this on Amazon, though. This is like a crimp kit. This is how you make them at home. They're actually pretty easy to make. You just plug in the cables, but I'm so lazy. I don't want to have to do anything. Okay, this guy has pre-crimped a ton of these. I don't know. Man, everybody's just doing these manually. GH1 1.25 9-pin cable but it's like female. I might need to not get this on Amazon. I'm probably going to pay up the wazoo to get it on Amazon too. It's probably no point. Yeah, there's all these kits. It's because people, like, a lot of people want to change their wire length, right? You don't want to, like, get stuck with a wire length. But the thing is I'm, like, basically working under the assumption I don't have a lab, even though I kind of have a lab. So, let's see if DigiKey has any. DigiKey is a pretty good vendor for this kind of stuff, though expensive. Oh, please. Don't make me crimp. Don't make me crimp it myself. Of course, AliExpress has it. Pre-crimped. I mean, this does look pretty easy. You literally just insert it. So yes, I have to make the cables, but it's relatively quick. And then we can do it for other JST board-to-board connectors. So I guess it's not that bad. I don't know. I guess I'll get it, and then I'll manually crimp it. I'll manually shove it in. It looks really simple. I think you literally just insert it, so it doesn't take that long. You don't need any special tool because they put this thing on the end, this little metal thing. I think that means it's pre-crimped. So I'll deal with it. Don't worry about little old me. I think I have a new business idea. We should sell these. Yeah, I want to get into the cable business, man. I think that's an intense business to be in. This is pretty cool though. I mean, hey, actually I'm kind of happy with this because like now we know we can like pretty easily like hook these things up. I don't love the crimping, but I also don't see a way around it. Eventually we can make our own display modules, right? Like we can, like all this stuff on the back of this, it takes this screen display thing, which is another standard connector. And it's just a circuit for controlling it with SPI. So it's like, and a lot of like capacitors, obviously tons of capacitors, but, Waveshare just makes these for convenience. Their like main thing is the display, not these little dev boards. So what we can do is after when we actually want to make tons and tons of screens, we'll make the board itself. And that'll be even better because we can simplify it and stuff like that. That'd be a cool project to do, but it'll be like less cool to watch because the end result will just be a board that drives the display. Basically same end result, but a lot harder to build the board that drives these. But then we could buy tons of these, right? If we wanted to buy 100 displays, it would be better to build our own display adapter boards. Probably, I would guess, but much simpler to use Waveshare for now. Anyway, good job. Appreciate you pushing that one through. I think you did really, really good. All right. I probably need to break for lunch. Is everything is somewhat wrapped up, I think. I think I opened like 3 PRs. Add row and column to grid function. That's a nice little PR for math utils. I have a PR to snippets to allow the importing of math utils, which is also very, very nice. Good night. Good night. Thank you. No, thank you. Thanks for working with me. Yeah, I was really frustrated thinking about that. It was a lot of effort, a lot of brain power. Yeah. We went down some pretty deep rabbit holes with fixes, so we never got to the benchmarking, but the benchmarking is my main focus today. So when I come back later, probably we'll take another look at the benchmarking.